right, we are going to continue on with page 45. This is the second part, and we are starting with problem number 4, which is x squared minus 6x plus 8. And so we are looking for the two binomial factors that would multiply together would create this original quadratic trinomial. And so the method that we were looking at was to use what we know about multiplication and to kind of work backwards to figure out those factors. And so if we repeat this, we look at this as x squared, which we know comes from x times x. And then what we have over here is a positive 8. And then remember that what we need to do is either think or list the factors of 8. So 1 and 8, and 2 and 4. And we need to check then for which set of factors are going to create this middle term, which happens to be a negative 6x. And so if I look at that, this 2 and 4, if I make one a negative 2 and a negative 4, are going to combine to make a negative 6. So if I multiply x times negative 2, that's a negative 2x. If I multiply negative 4 times x, that is a negative 4x. And so if I check here, there's my x squared. If I combine these like terms on the diagonal, negative 4 and negative 2, create that negative 6, and there's our positive 8. And so here are our factors that are answers. One is an x minus 4, and then the other one is an x minus 2. And we've talked before about how multiplication is commutative, and so therefore if you switched your negative 4 and your negative 2, the answer of x minus 2 times x minus 4 would be exactly the same as the x minus 4, x minus 2. Okay, both of these are correct answers, this one and this one, because when we multiply them back, we would end up with this quadratic trinomial. Okay, so let's continue on to look at problems 5 and 6. All right, so looking at number 5, we have x squared plus 2x minus 15. So I'm going to take and draw my 2 by 2. X squared. You might be wondering, do all quadratic trinomials start with 1 x squared? And the answer is no. We're looking at a specific type of quadratic trinomial where that a value, the leading coefficient, is equal to 1. Now here's what's a little bit different with this problem as compared to some of the other problems that we've done. This is a negative 15. So when I think about the factors of 15, 1 and 15, 3 and 5, if I think about multiplying those together to create a negative 15, what would have to happen is that one of these factors would have to be negative. It would either have to be negative 1 times positive 15, positive 1 times negative 15, negative 3 times 5, or 3 times a negative 5. So if I then look at my middle term, that's going to tell me how to select which one of these factors. I need the set of factors that when I add them together, I'm able to get a 2x. And so I start to look, well, if I add these together, that gives me a negative 14. If I add these together, that gives me a positive 14. If I add negative 3 plus 5, that is going to give me a positive 2, which is what I want. So I'm going to have a negative 3 and a positive 5. Now, I've just simply placed those. I could have switched that around and put the -3 up here and the 5 here. Now I'm going to look if I multiply x times +5, that's going to give me a positive 5x. And if I multiply -3 times x, that's going to give me a -3x. Now let me check to make sure I've done this correctly. Here's my x squared. If I combine these like terms here, this is going to give me a positive 2x. And there's my -15. So that means as I go to write my final answers, that I'm going to have one of my factors be an x minus 3, and then the other one of my factors to be an x plus 5. Now keep in mind that I may also have x plus 5 times x minus 3. What I do need to be careful about, and this is very important, that the 3 is negative and the 5 is positive, because we saw that that is what right here creates this positive 2x. If I switch it and I were to make it a positive 3 and a negative 5, I would have a negative 2x, which is not what I have in the original problem. All right, so let's take a look at another one of these. I can see that over here I have a quadratic trinomial, x squared plus 9x minus 36. I'm going to start with my x squared right here. That comes from x times x. I'm going to place in my -36. And then I'm going to write down the factors of 36. So I'm going to have 1 and 36. I'm going to have 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now, what I need to do is notice that I need to make a -36. And when I make a -36, that means that one of my factors has to be positive and one has to be negative. And so what that really means, if you think back to what we did over here with this problem, we selected this set of factors because I needed to make a positive 2. And if if I looked at 3 and 5, they were 2 away from each other. And then I made the 5 positive and the 3 negative, so that when they combined, I would have a positive 2. So if I need to look at a 9x, I need these set of factors to be 9 apart from each other. Well, 1 and 36 are 35 apart. 2 and 18 are 16 apart. But look at 3 and 12. 3 and 12 are 9 apart from each other. So now I need to decide, is this a -3 times a positive 12, or is it a positive 3 times a -12? And I let this term right here tell me how that's going to work out, because I need to make a positive 9. So if I look at this set right here, a -3 plus 12 is going to give me a positive 9 when I add those or combine those together. So that tells me I'm going to make one of these a -3 and one of these a positive 12. I'm going to take x times 12. I'm going to take -3 times x. And then I'm going to take and combine like terms. So here's my x squared, that's correct. The -3 and the positive 12 would make a positive 9, which is correct. And there's my -36. So now I'm ready to write my answer. When I write my answer, I'm going to have that this is x minus 3. And that this is x plus 12. And we want to remember that that could also mean x plus 12 times x minus 3. What it could not mean is that if we switch the signs and had x plus 3 and x minus 12, that would make a negative 9x in here, and we would not want that. So this is not a possible answer.